Today we're going to start talking about how forces interact with beams and structures and things like that, and show that it's not all that difficult. So let's start here. Let's say I've got a beam AB. If I apply a force that goes along the axis of the beam will want to move in the direction of the force. Now, if the beam gets connected to the ground, the force is transmitted through the beam to the ground at A. Then the ground will push back with an equal and opposite force, let's call it AY, and that force gets transmitted back up to point B. Okay, so now everything is in equilibrium because the forces at F and AY are going to balance out. And what we say is that when things are in equilibrium, they are static. They don't move, they don't change over time. Okay, but now, what would happen if the force doesn't go through the beam, but comes at an angle? Then the beam will obviously rotate, because now we have a torque on the beam. But what would happen if the beam can't rotate? Then the force is going to be transmitted through the beam, and the force will impart a diagonal force to the ground because the beam itself is at an angle to the ground. Okay, so some part of the beam is going to push down, and the other part is going to push left. Our question is, how much of the force is going to go down, and how much is going to push to the left? So, if you remember your trig, a diagonal force can be broken down into two forces, a horizontal and a vertical force. So let's try, if we can remember our trig, we can say that if that angle is theta, then the force, we can think of the force as the resultant force, and the vertical force will be F sine theta. The horizontal force will be equal to F cosine theta. Now, let's stop here for a second, because if you didn't get that part, then you're not going to understand anything else. So it's important to review your trig at this point and see that F can be thought of as the resultant force, with the horizontal force being the cosine of that angle and the vertical force being thought of as the sine of that angle. That's critical, or else no reason to keep going. So anyway, hopefully we got that down. Okay, so let's keep going. If we say F equals 100 pounds and theta is 60, then we can do trig and calculate how much force is going down and how much force is going to the left. And I'll let you take a look at that and check that with your calculators and make sure that you get the same answer. Okay. So we can then transfer those forces to our horizontal and vertical force. Now we know exactly how much force is going vertical, how much force is going horizontal. If we take and put a pin at point A, that's going to stop the pin, or stop the beam from rotating. So a pin is something that stops horizontal and vertical motion. The pin at A is going to stop the point A from moving either vertically or horizontally, but it can't stop the beam from swinging like a pendulum. It can't stop it from rotating, but it can stop it from moving vertically or horizontally. So let's put two other beams on here. We'll call them BC and AC. And in fact, now we have a rigid structure. We're going to put a roller at C. Notice the roller, all it can do is provide a force, we'll call it CY, vertical, up. It couldn't stop the structure from rolling or rotating. Pin A will stop the vertical and horizontal motion, C is only going to hold up the other side. So let's see how this will work out now. If we apply a force, then at B, then again, the force is going to transmit down through BC, and it will push down at C. It's also important to see that the beam BC will also try to push outward at C, and we'll take a look at that later. But right now, just see that the other two beams are going to have to react to keep beam BC in place. Okay, so that's one way we can look at it linearly. We can also look at it that the force would try to rotate the entire structure, and again, it would still push down at C. Both of those methods of looking at it, either causing a torque or just seeing the diagonal force, will produce the same downward force at C, and of course Cy is going to push back up with the same amount of force. Okay, so now let's also take a look at here. Have a horizontal force F trying to move the entire structure to the right. That's going to produce an equal but opposite force AX. So the pin AX is going to push and resist the force F, and C of Y is going to push up to resist the rotational aspect. Okay? This also generates one more external force. Let's take a look and see how this goes. So here's the force, and then we have these reactions. Now let's take a look. So we have, let's look at it horizontally first. We have the force F trying to push the structure to the right. That generates the external reaction force at A, meaning AX. AX pushes back the other direction. So A and F of X will each equal each other. I had said earlier that the force then goes down BC, pushes down at C. C of Y pushes back up. I also said too that the beam BC will try to push outward. That's going to have to be countered by the beam AC. So if you'll notice at point C, the beam AC starts pulling in the other direction. Okay, that then also, it is in tension, so it's pulling one way. If a beam, let's mention this, if a beam is either in compression or tension at one point, it has to be in compression or tension at the other point as well. So if we take a look at AC, the beam BC trying to push out, the beam AC is pulling back at point C, therefore it has to start pulling at point A too. So you see A of X is equal and opposite to AC. The force at F also is trying to, if it had the opportunity, it would take the beam BC and push it up at, again, if you look at B, it would try to push it up, and so the beam AB has to pull down to hold the beam BC in place. As it's pulling down at B, it's pulling up at A. Therefore, that forces the ground, A of Y, to pull down. So if you take a look at all of these forces, let's take a look at the external forces first. We have F being countered by A of X. We have C of Y pushing up, and we have A of Y pulling down. If you'll notice, we have our vertical and horizontal forces. All of them are F is equal and opposite to AX, AY is equal and opposite to CY. So our vertical forces are in balance and our horizontal forces are in balance. And if you take a look, We can also see that internally, what the forces that are on the beams, again, just one more thing here, you can see, as I just mentioned, the external forces AX, AY, CY generated by F, AX equals F, AY equals C of Y, equal and opposite. And then inside the beams, A of X is going to be equal and opposite to AC. AY is going to be equal and opposite to the beam AB. And then we can find BC by either looking at, if we looked at AB, we could say BC sine theta is equal to AB, and BC cosine theta is equal to AC. Just take a look at these and make sure that you understand it and how all the forces are balancing each other out. And then we'll go from there. Okay? Alrighty, so let's end this right now, and we'll go from there.